Hello everyone. Eh, In previous class we have learned few of the modules in Spring Data. Today we will continue some more Spring Data modules. After that we will go through one by one module inside what it is there, how it will work, how we will connect it to Spring Boot. Okay. Now coming to module which is there in the Spring Data R2DBC. It stands for Reactive Relational Database Connectivity. It is also one of the Spring Data family. Took is a specification to integrate SQL databases using reactive drivers, Spring abstractions, and repository support for R2DBC. Its main features are functional API. It has its own template, R2DBC entity template. Its support of different databases, H2, Microsoft SQL Server, MySQL, Postgres, and Oracle. Running statements for mapped entities using Criteria API built on top of Spring Framework's R2DBC database client. Parameter binding using the native syntax. Result consumption. Update count unmapped mapped to entities. Reactive repositories using @query annotated methods. Query derivation. Next, Spring Data REST. So it is also one of the Spring Data project family only. It is easy to build hypermedia driver REST web services on top of Spring Data repositories. Spring Data REST builds on top of Spring Data repositories, analyzes your application's domain model, and exposes hypermedia driven HTTP resources for aggregated contained in the model. Its features are Spring Data repository REST resources. It exposes a discoverable REST API for your domain model using HAL as a media type based on the Spring Data repositories. Pagination, sorting, dynamic filtering. Supports pagination via navigational links. Allows to dynamically filter collection resources. Query method exporter exposes dedicated search resources for query methods defined in your repositories. Lifecycle event hooks. It allows to hook into the handling of REST requests through Spring application events. Projections allows define client specific representation through projections. HAL Explorer ships a customized variant of the HAL Explorer to leverage the exposed metadata. Then another is Spring Data for Apache Cassandra. Apache Cassandra is a NoSQL database. It offers many new capabilities for teams seeking a solution to handle high velocity, high volume, and variable data flows. This new way of thinking introduces new concepts, and learning curve can be intimated to team members and team managers. Apache Cassandra offers a familiar interface for those who have used other Spring Data modules in the past. It has the Cassandra template and a SQL template, helper classes that increase productivity for common tasks as exposing synchronous, reactive, and asynchronous APIs. Schema support, creation of key spaces, tables, and indices, object mapping, lifecycle events, repositories, observability, Kotlin. These are the couple of features for Apache Cassandra. The same way, Spring Data for Apache Geode. VMware announced general availability of the Spring for VMware Gemfire projects. Spring Apache Geode project still maintained until OSS and commercial support ends. Maintenance only includes CVE and critical fixes. The primary goal of Apache Geode project is to make easier to build highly scalable Spring powered applications using Apache Geode for distributed data management. Its feature XML namespace, annotation configuration model, simplifies working with Apache Geode APIs, abstraction backed by API Apache Geode. Next, coming to Spring integration. Sorry. Spring Data Couchbase. So Spring Data Couchbase is a part of, again, it's a Spring Data family. This Spring Data Couchbase projects provides integration with the Cowbase server database. Key functional areas of Spring Data Cowbase are POJO-centric model for interacting with the Cowbase buckets and easily writing a repository style data access layer. Spring configuration support using Java-based @configuration classes. We have Cowbase template helper class that increase productivity programming common Cowbase operations including integrations, object mapping between documented and POJOs. Again, it has cacheable, then Cowbase server versions 4.0 repositories can still be backed by Cowbase views. Then Spring Data Elasticsearch. What it provides is integration with the Elasticsearch engine. Key functional area of Elasticsearch or POJO-centric model for interacting with the Elasticsearch documentation and easily writing repository style data access layer. Which earlier I mentioned all the data models or what all the database submodules will work for the same purpose with the different features. Each module will have the different features. So based on the requirement of the project, anyone can use these different modules to connect to database and work with the database technologies. Spring Data Enverse. Again, this also it is extension of the Spring Data JPA. Project allow access entity versions managed by Hibernate Enverse. The source mostly originate from a contributor Philip Humuller. Okay, Spring Data Neo4j. It is also again family of Spring Data. It provides easy configuration and access to Neo4j graph databases from Spring applications. It offers three different levels of abstraction access the store. Neo4j client, Neo4j template, and Neo4j repositories. Spring Data Neo4j offers advanced features to map annotated entity classes to the Neo4j graph database. Its features are different levels of abstraction based on the Neo4j Java driver. Immutable mapping, Neo4j client for low-level abstraction, Neo4j template and repositories and high-level abstraction, supports for Spring conversion service, custom query via @query. So these are the different submodules under Spring Data. In our next class, what we can do is we will see the description of the each module thoroughly and how with the sample example what is the difference between each and every module, how it will work. Those things we will verify it. So we can learn in depth of each module. So then you can understand how these each module will work. Okay. Thank you very much for your time. Have a nice day.